I'm going to have the distinct pleasure of introducing Paul Epstein to you. But before I do that, let me just say that, as I think all of you know, Google.org is involved in 3 areas: the global climate crisis, global health, and global poverty. These are very iterative things. As people emerge from poverty, as they have in China, they use more electricity. As they use more electricity, then the energy thus consumed creates more carbon. As that carbon goes into the atmosphere, temperature rises. As the temperature rises, those places that are amongst the poorest in the world get inundated with water. So if the climate crisis continues, China has remarkably taken 300 million people out of poverty and thrust them into the middle class. Unfortunately, there's another 300 million standing in line behind them, and another 300 million behind them. If they all go in the same way, consuming the same amount of energy, Bangladesh will be underwater, and there'll be 100 million Muslim Bangladeshis who become refugees in Hindu India and into China. And the same thing is true with the relationship between health and climate. Places in Africa that were established at 6,000 feet because the Anopheles mosquito, which carries malaria, couldn't go to that height. Now they can go to that height. So you're seeing a total interaction between the climate change, between global health and poverty, each feeding the other. And I'm so pleased that Paul is here today. And Paul and I have known each other for, I won't tell you how long, but Paul and Fitzmullen, who's over here, who's at George Washington, Fitzhugh Seamus McManus Mullen, the 3 of us were all interns together back in 1969. That's how far back we go. And Paul now is at the epicenter of all the things that Google.org does. He is the head of, or the associate director of the Center for Health and Global Environment at Harvard. He is working on the interface between climate and health. He lived in Mozambique for a long time, speaks Portuguese, travels back and forth to Africa, has worked with Brazilian immigrants in Boston, is a physician, is an epidemiologist, has a master's in public health, and is one of the most widely respected people in the world at the interface between the climate crisis and global health. So please join me in welcoming Paul Epstein. And you've got that one.
I've got this.
So if you're turned on. Okay, you're cool.
That's it. Hello? Yes. Well, thank you, Larry. And it is a great pleasure to be with Larry and Fitz and with you all. I was going to start with 1996 when we started our center, but because of this confluence, I'm going to start in 1854, just for a second, where Rudolf Virchow, who was a physician and a surgeon, took to the streets as an activist and said, cholera, smallpox, TB in London. You know this story with John Snow, but behind it, there were some physicians, medical people, nurses, I'm sure, who were talking about the social and economic and environmental determinants of health. And that helped create this whole movement, which actually led to a leveling off of those diseases. So that's the good news about an intervention. Back in the 60s, we were active in the Student Health Organization, the Medical Community for Human Rights, and I could go on and on about our work, but I do this introduction because our center was founded by myself and Eric Shivian, who came from the International Physicians for Prevention of Nuclear War. I think I'm going to take this off. And the IPPNW, Physicians for Social Responsibility, had the position that the health consequences of nuclear war could help turn public opinion, policymaker opinion. And that played a strong role. They got the Nobel Peace Prize for that work to stop nuclear testing. Later, with the Montreal Protocol and stratospheric ozone depleting chemicals, physicians also played a role. Dermatologists, immunologists talked about the health consequences. So all that is to, oh my gosh. All that is to say that we've started this center at Harvard Medical School to look at the health consequences of global environmental change, biodiversity, climate change, as a way of communicating the direct issues that have come to our backyard. It's not just about ice, polar bears, it's also about our health. And since we are waiting, our center is founded on 3 pillars. We do education primarily for medical students, but we draw from the School of Public Health at Harvard, Divinity School, Business School, Kennedy's Government School, Tufts, Fletcher School, journalism students. And that is on the web, broadcast free, as you do things, to 65 medical schools and some overseas. We also do education for policymakers in DC. We do a 2-day course for legislative aides and give them a condensed view of this course. And we do briefings on climate and health and agriculture, climate and health and marine systems. Finally, we do research on climate change and biodiversity, and we've done a number of experiments with folks at Harvard. And so I won't go on about that, but that's our center, and we're celebrating our 10th year. This year we have a Global Environmental Citizens Award, and last year was Al Gore got our award from Meryl Streep. So that's our claim to fame. Okay, I'm going to talk about something in 3 parts, and I'm going to try to talk pretty fast so we can have a discussion. Climate basics, climate and health, and then talk about solutions and how we can think about health in terms of which energy solutions we need to adopt. Back in 1991, there was an outbreak of cholera in Peru. So those are algal blooms. Galapagos are about 500 kilometers off. Turned out that warm sea surface temperatures and extreme events, which flush a lot of nutrients into the environment, helped create these algal blooms. They were a nidus for cholera. That was the work of Rita Caldwell, who later went on to run the National Science Foundation. And so that cholera came in 3 different places, and those connections between climate, environment, and disease began to be made. We went to the Rio Summit in 1992. I was telling Larry. We presented this. People said, what are you doing here? Physicians, medical people, this has nothing to do with the environment. Well, no one got this. No journal published it, except one journal. That was the Wall Street Journal. Shrimp exports, tourism. And so this is a theme that carries me through this work that leads to our report, which I will tell you about in a moment, of health, ecological, and economic dimensions of climate change. And indeed, this is a way of looking at the results, the downstream consequences of the upstream conditions and causes, and the downstream costs that can help think about development as well as health and climate, and how energy is key to all of those. Okay, this much we know is true. The IPC, the Intergovernmental Panel on Climate Change, 3rd assessment report was 5 years ago. Climate is changing, humans are contributing, biological systems are responding on all continents and in the oceans, and weather is becoming more extreme. So that's 5 years ago. Since 2001, we've learned a great deal more. Carbon, I don't know if I have a pointer here, but that's all right. Carbon dioxide is now up to 380 parts per million in the atmosphere. Oh, great. This is it. Thank you. What this is an ice core record that was back to 420,000. Now it's back to 750. Probably 2 million years ago, when the Panama Isthmus closed off and the Gulf Stream started, we started oscillating between large ice caps and medium-sized ice caps. between 280 and 180. Reverse that. 180 was the ice age, the large ice cap. We are now outside that envelope that we've been in probably for 2 million, perhaps back to the dinosaurs in 50, 65 million. We are pushing the envelope, as it were, on the feedback mechanisms, the ocean sink, the land sink, that has helped stabilize climate for 2 million years. Clearly for the last 10,000 years, that's our Holocene that's been so hospitable. So hold on to the Holocene is our cry. Hold on to your hats. We are pushing this, and this is really where we're. And I must say, this cycle of Earth around the sun and its tilts and its wobbles and eccentricities is what has driven these cycles. The latest calculations are that we were not about to come out of this Holocene anytime soon. So we really are changing what was the trajectory. Polar and mountain glacial ices melt is accelerating, ocean temperatures are changing, and winds around both poles are becoming more forceful. That's probably the scariest thing I'm going to say. What's happening with the ice? This is a slide which shows you the difference in the melt during summer over this 10 years. What we're now seeing is an acceleration. Some of these outlet glaciers are melting at 14 kilometers a year, 8 or 9 miles a year. 5 years ago, they were going at 7 kilometers a year. We're seeing now melt of Greenland ice 3 times what it was between the 1997 and 2003 period. It's 250 cubic kilometers. It was 80. So we're seeing rates of change. These are derivatives. This tells us something about systems. And so just to look at systems for a moment, this is the kind of issues that now the IPCC and scientists are dealing with. It's not just numbers of 380 parts per million or 450 or 550. We're talking about rates of change, volatility, novel events, anomalies, and changes in multiple components, because it's really the bathysphere, the cryosphere, that's the ice. It's the biosphere, the atmosphere, the stratosphere that we are playing with here. And that means that if we all sat around this table and pushed, it's more apt to go over. So we're looking at how we look at change. Change can be abrupt, it can be stepwise. We look at also in this report, this climate change futures report that we did with Swiss reinsurance company and the UN Development Program, look at impacts and how they can change abruptly. And this is perhaps the main contribution of this kind of thinking about forests, about our health, about marine life. Okay, a couple more on this climate stuff. This is the pictorial of what's happening to the tropical oceans. They're becoming warmer and saltier because warm water evaporates. And up north, because of all that melting and rain falling at high latitudes, we're seeing cooling and freshening. Now there's a pump up there. When it's cold and salty, as it's been, it sinks, and that pulley system pulls up the Gulf Stream, and that sets in motion this conveyor belt that has helped stabilize climate for this 10,000 years, and for during these periods of change, we see a change in that conveyor belt. What's happening now is that because of that freshening, it's layering across, and we're seeing a slowing down of that pump. That circle that you see is the Gulf Stream coming up and going around. It's the same as the trade winds that brought rum and this way and slaves this way, and the whole triangular trade from our 12th grade. That was driven by the trade winds. That drives the oceans. We're seeing a 30% decrease. That's the kind of projections that were made for 2100. We're seeing storms like Katrina that are the kind of storms we were projecting for about 2080. We are seeing changes that we projected later on in the century happen today. And thank goodness we had a very nice calm season, and we in the public are giving out a sigh of relief, as are the insurance companies. Here's what happened about 12,000 years ago, there was so much warming and melting that the Gulf Stream shot straight across to Europe. The ice returned for about 1,300 years. That's the day after tomorrow scenario. It's the Pentagon scenario. It's the National Academy of Sciences, abrupt climate change, inevitable surprises, all which led to that movie and that scenario. Can this happen? Well, it can, and I guess the most positive scenario I want to remember to give you is that maybe this will shut down, but we have so much warming that we're not headed towards an ice age. So that's my comforting word for you. All right, what does this mean for bottom lines? And we're going to come to health in a moment. For the financial world, we see a change in the catastrophic weather events, and these are primarily those. This is from the IPCC, and it's in small letters, but mostly weather-related events. We saw a change of 1 order of magnitude from the 80s to the 90s. In the last 2 years, we've seen another stepwise jump, about a half a log. This has been enormous for the insurance world. They've seen this stepwise functions again, and indeed insured losses go up about 200-fold because of all the storms in Europe, the US, and Japan. So we've seen a shift actually in extremes from Mozambique, Honduras, Venezuela in the 90s to now more extremes occurring in the north because of all of these changes in the North Atlantic. So we can tie this to climate in a really plausible, dynamic way. Well, are those losses due to climate change? Well, yes, we're living near the coast and the Gulf. Yes, real estate prices are up. Yes, insurance penetration is up. And that's the key word, there are more extreme events, more different kinds of extreme events. So it's not an either-or issue. Climate change is playing a role, as there are economic vulnerabilities as well. Let's look at Katrina, Rita, Wilma, this whole episode for a moment. The lake was having waves come across it that were much higher than the levees. As we look to rebuild these levees, we're in a quandary because the power of the storm was greater than the levees. Those coming off the Gulf were much higher than the oil rigs and knocked a lot of the oil rigs. It's still 25% down in terms of oil and gas in the Gulf. Think vulnerability of the energy sector. Between the refineries, the pipelines, and the oil rigs, they're still down. Life and health, property and casualty. Forgive me, this is insurance speak, but these are the folks that I'm working with now to talk about the implications of all this. But we're seeing a new disease occur. Katrina cough, you've seen people with masks. Toxins, oil spilled the size of the Exxon Valdez, 11 million gallons. We're not even thinking about this, but it's in the wetlands, it's a mess. And mold, floods foster fungi, one of our mantras. Food security was affected circuitously. It was sent from southern Africa to Asia, but it got hung up on the barges in Mississippi. Energy prices and political instability. And I'm not a betting man, but I would bet that the price at the gas stations will go up in about a month, if you get my drift. We've seen changes for many countries, and just as in the 70s, when oil went from $3, I don't know if you did get my drift, but I think there's been manipulation of the oil prices that has been in the New York Times editorial, I would quote. And whether that will change after the elections, we don't know, but it's a possibility. I don't want to give any hidden messages here. It's all out, transparent. So in the 70s, the oil crisis, $3 to $30 it went in several years. Gold went from $38 to $600. That probably bought apartheid regime about 15 years longer than it would have had because of the price of gold, and they were such a source of gold. Well, it destabilized many countries. And there's a wonderful movie, Life and Debt. If you haven't seen it, I recommend. That talks about that period and the debt that began in the 70s, led to the petrodollars and the investments, and then inflation in the 80s and specudollars in the 90s. It all started with that loosening of Bretton Woods rules, and we'll come back to that in a moment. But the price of oil had a lot to do with the instability and failed and fragile nations that we face today. It's affected our image, and it certainly will affect our politics, if not this election, next election. But clearly, energy and climate are key to our development and our healthy development. If there's one number that I want to leave with you in this talk is 22. This is work about the heat in the oceans as compared to the atmosphere done by folks at your Department of Commerce, Sid Levitas et al., NOAA, National Oceanic and Atmospheric Administration, Tim Barnett out here at La Jolla and Scripps. What they found was that the heat in the atmosphere is dwarfed by the heat that's accumulated in the deep ocean. This is central to this understanding of the changes of the heat budget on this globe. Water is warming, ice is melting, water vapor is rising. The hydrological water cycle is accelerating. It is affecting land areas in terms of greater evaporation and more intense droughts. It's also getting more water vapor hanging up there, and when it does cool and condense, it comes down in dumps, downpours, which is lovely in St. John in the afternoon, but not so good in California. And it's also what contributes to more precipitation falling during the winter as rain and snow because of the warm winters. And you are well aware of the issues of snowpack in your close mountains here. So this is what's key. It's the joules, the heat in the deep ocean that is driving the changes in weather. And this is what's central to understanding the dynamics behind the storms, the droughts, heavy rains, and so on. Okay, health issues. And please throw your hand up at any point if there's something that you need clarification on. But malaria is clearly one of the key health issues, and I don't need to belabor this, but we've looked at the economic dimensions as well as the human costs and so on, and clearly needs interventions in terms of defense, public health, as well as how we look upstream. This is what Larry alluded to. What we're seeing is a change in the mountains in Africa and Asia and Latin America, where glaciers are receding, plants are migrating up. We're seeing that in the Alps as well. We're seeing in the Sierra Nevadas here. And mosquitoes are circulating at high altitudes. So Nairobi, which is a mile-high city, now has malaria circulating in it. And we're seeing this in Colombia with Aedes aegypti. We're seeing it in Papua New Guinea. We're seeing it in Nepal. And this is a consistent picture of this change in the isotherm and permafrost that we're also seeing in terms of latitude. These are some projections with Lyme disease. Now, Lyme disease is a complex disease that you don't have in this coast because of a lizard that has an antidote to it, as it were. So there's biological diversity issues. There are deer and lots of mice and few predators of deer. So there are ecological issues. There are social issues. We're living in suburbs and sprawl. Warming is also changing the latitude at which these ticks can circulate. So these are projections with a computer of what can happen over this century in terms of the expansion of the area conducive to circulation of Lyme. And this is an issue in Europe. It's an issue in the Midwest. And we've seen this year, I don't know here, but we're full of squirrels and full of acorns. It's a massed year. It's driven by climate signals. At any rate, this is a big year for ticks. So there are a number of reasons, but warming allows the overwintering of these ticks. Asthma is an issue that in medical school we learned was socioeconomic, perhaps some allergies, indoor pollutants. There's a whole range of issues, of air quality issues under the radar that are all related to fossil fuel combustion. Let you just look at that for a moment. I'm not going to go through all these issues in detail. Ozone, you're well aware of. Study in LA showing that that can initiate asthma, not just make it worse. Floods and fungi, I mentioned in the Gulf Coast and so on, diesel part. What I want to call your attention to is this tree and weed pollen. We did experiments in greenhouses with ragweed. Doubled the CO2. So this is, forget climate change for a moment, global warming, all those conclusions, just CO2. There have been a number of skeptics that have said that will green the planet. It's going to help agriculture, help forests, take it up. Well, what we hadn't foreseen is that the weeds love this stuff. This is a perturbation, a stress for them. And they like to put this carbon dioxide into their pollen, which is their male part, territorial seeking part, to spread their wings. This is happening with poison ivy. Poison ivy is getting a boost from carbon dioxide and getting more toxic. So if you've noticed poison ivy, you can blame it on climate and carbon dioxide and burning fossil fuels. We're seeing this with agricultural weeds. We're seeing it with some soil fungi. And this, of course, is a major source of illness. It's the 6th leading cause of chronic disease in the US. There's a CO2 dome under the cities that mirrors the heat island effect. And I put this up here because it also begins to look at solutions. So 7 degrees greater, CO2 gets trapped in Phoenix, in LA for sure, New York. And so there are issues of abandoned lots and ragweed, et cetera. But this also points towards solutions of green buildings, rooftop gardens, tree-lined streets, pedestrian bicycle paths, smart growth. All of these issues are good for our health in the inner city in terms of diesel and so on that actually helps deliver these aeroallergens, so there are synergies. But it also begins to drive the markets for these energy efficient and alternative energy technologies. Dust storms from Africa, and I'm winding down on the health issues here, but dust storms the size of the US are coming across each year. They deliver dust, they deliver some fungi to the fan coral. Kids in the Caribbean, kids in Florida are getting asthma at rates of 25%. There used to be less than 1 on some of these islands. Global change, overgrazing, drought in Africa, some of which is climate related. There's really been a drought in sub-Saharan Africa since 1965. These are enormous, vast changes that also affect us. From China, we're seeing dust come to your coast and affect air quality in California and in Denver. I don't know if it's making it over the Rockies. Okay, one of the issues is heat waves. Clearly, this 2003 was a major outlier, 6 standard deviations from the norm, lots of deaths, lots of issues for the environment, for crops, for livestock, nuclear plant shutdowns, and we'll come back to that as we come to solutions. Alpine glaciers lost 10%. They've been losing about 0.7. So this is not just an event that's a blip on someone's chart. It's something that lives on in the history of the lakes and the water for Switzerland. Wildfires is clearly something we're seeing here today, so I guess we should talk about this. But clearly arson is the arc, but we're seeing more wildfires, more areas that are fire prone because of warming, because of low snowpack, and so on. One of the hidden issues is that the bark beetles, and you have them right here. This is mentioned in the New York Times piece about this the other day. And before I forget, New York Times today has a major article by Andy Revkin about all the solutions that we'll come to. But here we are back with the bark beetles. And as we think about health, we're thinking about the health of wildlife, livestock, forests, agricultural systems, marine life. Here's a pest here's the agent, here's the host, here's the environment. If you're familiar with that epidemiological triangle, the hosts are getting emboldened. They're going to higher altitudes, higher latitudes, overwintering, sneaking in an extra generation each year. The hosts are getting weaker by this alternating drought and then heavy rains. Drought dries the rosin in the bark that drowns the beetles as they try to drive through the bark. So the hosts are affected by the extremes. The pest is affected by warming. Those are the 2 parts of climate change, warming and more extremes. And here we are with fires. with injury, respiratory disease, et cetera, and a carbon pulse. This is the Kenai Peninsula. So this is from Arizona through California, up through Vancouver to Alaska. This is an issue. And on the East Coast, we're facing woolly adalgid that's affecting the hemlock trees that are lovely trees where the moose breed and lie during the winter. These are the umbrellas. And in the Midwest, there's an ash tree disease. We're seeing this in Europe. This is more and more an issue for our habitat and assets, as it were. But right now, before we think about money, just our habitat that is also being affected. And I should say that this battle between insects and trees is much older than the battle between malaria and dengue fever and us. This is about 325 million years when the trees started growing on the earth, the insects started rebounding, the trees started to defend themselves with chemicals like cyanide and bark, and then birds came along. That was the Carboniferous period where all the fossil fuels were buried because of the dying of the trees and the battle with the insects that was fortunately won by the trees. But what I'm hinting at here is that this battle may be more crucial for our livelihood, our public health, and underlie our oxygen and watersheds. This is something Al Gore seized upon when he came to visit us and looked at this destabilization of the battle between insects and plants, microorganisms and us, and so on, that climate change is contributing to. Okay, to end this part about health with the next couple, extreme weather events. This is just a mapping exercise we did with extremes and floods and droughts where hantavirus, dengue fever, malaria, this was in Science in '99, and I'll make all this will be all on the web. If we look at oil and its life cycle costs, we look at refining, extraction, exploration, and transport, and clearly there are developing nation vulnerabilities, but as we saw, no nation is immune, and this isn't just from Mozambique, the floods in 2000 where malaria spiked 5-fold. So again, extremes may be more crucial than the warming itself. And for us, variability, freeze-thaw cycles, well, that's important in terms of migration of birds that carry avian flu, and if we want to, we can talk about that. But allergies, we saw last January in DC and New York, people were starting to have itchy eyes around January, and maple syrup was flowing, so food security, Lester Brown is concerned about these mismatches of pollinators and so on. And so finally, these are 2 slides to summarize this climate change futures study with Swiss reinsurance that insures the insurers and the UNDP. Looking across some of the costs, again, asthma, 4-fold increase in the US since 1980 and in many developing and underdeveloped nations. Then we stepped to the other side and looked at the streams, the floods and the droughts, and how they might lead to clustering of rodent-borne, waterborne, and insect-borne disease. And then here was the central part that linked us to industry, because we looked at these diseases, pests and diseases of these natural systems. And I won't belabor all of this, and this is on the web, but just call your attention to coral reefs. $800 billion is what the estimate is per year of the goods and services. We're talking livelihoods, fisheries, hotels that are buffered on tourism, and so on. 26% are lost because of warming, bleaching, and disease, over-harvesting, and nutrients. These are multi-causality. But warming is clearly what could knock this off. And this is the kind of abrupt change in impacts to forest and marine life that actually contributed to the Stern Review. If you look in any paper today, I think you'll see a report of the Stern Review, which is advising Tony Blair. And we briefed them. They're looking at the costs of inaction. They estimate it could be up to 20% of the global economy, as opposed to 1% if we tackle this clean energy transition. And they were looking, again, at the potential for abrupt changes in impacts. Okay, this is the last, the energy sector, just to say that that is also vulnerable. We mentioned the Gulf. There's also blackouts and heat waves, cooling water. They want to drill in Anwar, in Alaska. Well, the pipelines are really fragile. They're getting undermined by the melting that's affecting communities and livelihoods and alcoholism and all the rest of the stuff that's in the Arctic climate impact assessment that I've mentioned to you. Lightning and warming, we learned from the Hartford Boiler Inspection and Insurance Company that warming actually makes more lightning, so wildfires again. And then there are, of course, feedbacks. This is a major one in terms of firewood being used for the energy for indoor cooking and health, all the health issues related to that, and the deforestation and the carbon sink. And now in Peru, they're planning for some new coal-fired plants because they're losing their glaciers and hydropower. All right, lots of bad news. My friend Richard Clapp, who I know Fitz knows, should subtitle his talk. It's worse than you think. So let me go to some solutions here. And I do believe there's a confluence of forces that are going to lead us to deal with this and a convergence of agendas. Climate instability, we've talked about. Peak oil is the other thing that you're hearing about. It may not have peaked, but it will peak. This is finite. It's finite resource, and limits to growth may have been 30 years ahead of its time in the 60s or 40, but there are limits to these finite resources. Energy sector vulnerability, environment, we talked about. We could talk about the Nigerian Delta and all of the issues of the environment. Here are all these conflicts that one could tie to oil, and I must remind us that even our president has said we're addicted to oil. So I like to say that's the first of a 12-step program. All right, these are the levels of response. And for public health, we look at defense and bed nets and treatment and malaria treatment with medicines and so on. These are the public health defenses. We also look in public health at how we can have adaptation, whether there are early warning systems using El Nino forecasting or climate, so on. How deforestation makes you more vulnerable to floods and so on. And then we look upstream, the real upstream. We can look at the energy system as one of the key first, not sufficient, but necessary steps towards clean development and sustainable development. Here's one of the ways that we're thinking about solutions is this wedges effect. This is work of Bacala and Sokolow, and actually Andy Revkin's piece today talks about this. How do we bend the curve of the carbon emissions? By 2050, how do we not produce another billion, a gigaton is a billion tons? How do we get 7 billion tons less to stabilize the concentrations? So we actually have to stabilize the emissions to stabilize the concentrations, but this is a first pass at 7 kinds of solutions. All right, here's the 15 that are put forward in this science piece by these Princeton folks. And I'm just going to put this up here and give you a sense of how we in public health and ecology and economics might begin to think about this. And this is something that I take into Citigroup Asset Management and Moody's and Standard & Poor's and talk about where do you put your money now? And that's true for Google as well. How do we think about the health dimensions of solutions? So here we are as a rating system. And I'm putting this up in a group. CAFE standards, doubling them, 30 to 60 miles per gallon. We could have plug-in hybrids. You're all moving towards that here faster than anybody. Demand-side management and how we look at efficiency. We use twice as much energy as Japan and Europe for all we do. Green buildings, so on. Wind, well, siting is an issue, how we do that you're very aware of. PV, well, that's clearly, it's all solar ultimately. That's where all the energy comes. That's clearly solar, thermal, so on. Forest management, I won't say, but nurturing. Conservation tillage, well, we already got 7 here. If we moved ahead, we'd begin to really approach this model. Then we've got a whole bunch that are fossil fuel based, carbon capture, hydrogen fuel cells. We've got to study these. We can put a lot into the ones with no regret, but we need a lot of R&D for the others. And then nuclear fission, I'm just going to put 3 S's on. Oh, good. Go ahead.
What is else?
It's a good life cycle analysis. So just as for oil, exploration, extraction, refining, transport, and then combustion, all of which lead to problems for public health and the environment. For nuclear, this is very apropos. We can look at the life cycle from the mining and the dangers there, from the transport, and that's what the Germans are on the road trying to protest and so on. And then you come to milling, and then you come to the plants and the use, and then you come to the storage. And the storage, you all know, Yucca Mountain, we've been studying it for years, $60 billion, we haven't solved it. In order to make 1 wedge from nuclear, we would need a new Yucca Mountain every 3.5 years. We haven't solved one, the French haven't solved it, the Swedes think they might have found a clay place to tuck their stuff. I actually talked before the Nuclear Regulatory Commission a week ago, and until this slide, they were all with me, and then it was like, who let this person in? It was like a movie. But, so 3 S's, storage, safety, and security is clearly a big issue. In England, anyway, we have multiple problems that, I was going to mention sea level rise, because all of the nuclear plants are on the coast there, and the insurance world is worried about that. At any rate, I think that these are issues that we're all going to have on the table, but I just came from the SRI, the Socially Responsible Investment Group in the Rockies. There, too, people are questioning whether we should do nuclear. I think from a health perspective, environmental perspective, we have to take a strong position that this is something we should not replace carbon pollution with radiation pollution. I'm not including it just because it's, yeah. I mean, and this is from the paper by Pakala and Sokolow, the 15 wedges and how much land it would take for biofuels, and they look at, and they don't have fusion. I don't know.
What's available now?
Right.
What they develop.
Fusion, we can talk about it. It's in a glass. Fleischmann and Pons, I don't know. If we can create the sun in a glass where it's not really that hot, I don't know what that'll start. So anyway, that's my physics background thinking about that. So green buildings, just for a moment, part of the solution, clearly. Many health benefits, many economic benefits, worker satisfaction. You have lovely light here and lovely building. I'd like to learn more about what you do here. Kids do better in schools with tests. People buy more in stores with sunlight. That should move the Wall Street. And patients do better when there's better ventilation and so on. For developing countries, and this is the penultimate slide, we can think about all of these distributed local development issues that need energy. And solar and wind, and then you could hook a wire around there and get a bicycle and use, when the sun doesn't shine and the wind doesn't blow, get folks to ride around on a bicycle or run around or horses. There are ways of having distributed generation with clean energy. This can pump water, purify water. It can cook, it can drive small development. This is something that groups like ECO and CO and so on that I just saw at the SRI, there are groups that are pushing this because clearly this is an issue for poverty, for clean environment, for energy. This is a precursor. So finally, I believe that we need to think about the policy issues as well. And this is what Amy and I were talking about. And businesses are beginning to think about this. Wall Street's beginning to think about what are the enabling financial instruments, policy instruments, and framework. So just to put out a potential way of thinking about a framework, here's the carrots, here's the sticks. Incentives, want to lead with those. We need to align our rewards and regulation systems from our own walking and biking to what we do in our communities, in our churches and synagogues and where we work and so on, with what companies do, what the government does. We need a new energy plan that deals with all of the issues of transport and housing and utilities. This can be the engine of growth for this 21st century. This can be jobs, put people to work with the right international framework and funds. It can be a spark for development with removal of the perverse incentives and disincentives. So we're talking about rules here, and I want to emphasize that word. Lead with the carrot to get the horse moving. This clean energy transition and transformation can be good for public health. It can be good for security. It can be good for the economy. And we certainly hope it'll stabilize the climate. These are our websites, and I thank you very much.
Thank you, Paul. I think you've crystallized a lot of the thinking that we've been doing here at Google and google.org. Are there any other questions? We've got about time for two. Yes.
At the beginning of the talk, you mentioned that the strengthening of the polar winds was one of the most disturbing things to you.
May I ask you to say that again so NSA can hear you?
At the start of your talk, you mentioned that the strengthening of the polar winds was one of the most disturbing things to you. Can you please briefly explain why that's so disturbing?
Well, it's a good question, because gradients is really what we're talking about. Again, back to the systems thinking. And if we're getting cooler up there and warmer down around the tropics, we're changing the winds. Winds flow, and hot air rises and creates a low system, and weather flows downhill, as it were, from high pressure systems to low pressure systems. So as it cools around the poles because of this melting, we're getting changes in the gradients. It's changing the winds. That's changing the weather. So pressure, temperature, pressure, wind, weather. TPWW is basic physics. And we're seeing windstorms go deep into Europe. They had 3 in 99, Lothar, and so on. They had one last January that knocked a year's worth of forestry out of Sweden. We're seeing deeper penetration of some of the winds as these polar temperatures and pressure gradients change. Wind is concerning. Wind is that element that cools you, warms you. It's your friend, it's your enemy, and it drives trade and so on. So if we're changing winds, that's disturbing. But I do want to remind myself to say systems like stabilization. They like equilibriums. So I do believe that we can go towards a new equilibrium, but we've got to back off the pressure we're putting on this system, some 60 to 70% in terms of greenhouse gases, to stabilize the concentrations.
That was the comment that I was to make, because not in Al Gore's film and in your lecture, there was emphasis on the nonlinear aspect of climate change. And I think people have this feeling that, yes, we will start to do something and then things will start reversing fast, as they did with the ozone hole, where we see some signs of improvement now that after the Montreal protocols. But I think, and what I've been taught at school, the climate system is much more complex than that. And the warming of the ocean may actually be a barrier to going back into this stable state we had pre-CO2 level, pre-high CO2 levels. So I would encourage everybody speaks on that to really emphasize that point. I mean, if we start doing something now, that's not going to change anything, because these systems may settle into an equilibrium state and then stay there for a longer time.
Absolutely agree with you, and that's fundamental. We've had large ice caps, medium-sized ice caps. We're headed towards small ice caps. I did want to present this in a positive light, then, that there is a potential that we could stabilize at another state that gives us a chilling off period, as it were, to go ahead quickly with this clean energy transition. It's possible we've headed towards that. No one understands what the heck happened this year with no hurricanes. it may have to do with some of this ocean circulation melting and cooling off and convection and burying some of the heat.
My question builds on that general point. Given that Nick Stern's report has also confirmed the fact that we need to act now and not later in terms of economic costs, how do you think we can incentivize governments to put the incentives you alluded to in place, given that sometimes political motivations conflict with those goals?
Good, that's a good, huge question. And what is the framework for sustainable development that we all cherish? There are three things that are in the way. So we've really got to, before we think about all the incentives, we've got to think about all the incentives that are leading people to take down their forests, to send for timber or clear and grow cows for hamburger, for McDonald's, et cetera. So the debt is key. The debt that we got into from the 70s, based on oil in large part, is driving much of this fragility in terms of states and failed nations. There are perverse subsidies for oil and coal that are clearly larger, and our wars and so on are, I think about $1 trillion is what Tom Friedman in the Times estimated was what we're spending on Iraq already. So what we do for wars as well as oil lines. So there's a whole perverse subsidy issue that's driving this. And then the fundamental one is the terms of trade. Something we don't talk about a lot, but what the Rwandans are getting for their coffee is what they got in '62. What they pay for a hamburger or a tractor is what you and I pay. We've got to equalize the terms of trade to get, so it's not just fair trade now, it's doing the rules and the agreements of trade as to make it fair. So those are three obstacles. And then we've got to provide large funds that are global funds for adaptation and mitigation. And here, clean energy, I want to emphasize, is an adaptive measure because it's distributive, it protects when there are storms and blackouts and heat waves and so on. So it's part of adaptation that isn't usually talked about, and mitigation. And then we need to provide some institutional framework for this. So we need those three. We need the carrots, the funds. We need new rules and regulations and rewards. And we need some new institutions beyond the Bretton Woods ones, which is the last time we came together in '44. And Keynes got the brilliant idea. We didn't need to change, he figured out we didn't need to figure it all out. We needed to just change the rules, change the financial signals. And it was it was liberal trade in goods, but fixed exchange in capital. You can't just move it from Seoul to Thailand, and I know we have to stop. And finally, the fixed exchange rates at $38, that was all abandoned in '72. So anyway, we've got to come back to new rules, new incentives, and new kind of institutional framework to move this. And I think you're in a wonderful position to think about the new technologies and to think about this framework and policies and how businesses and environmental justice groups and so on can all get behind something that can provide jobs and development as well as a healthy future.
Before we thank Paul, I just want Amy and Kirsten to stand up just so you see them. If you have any follow-up questions on the environment, please speak with them on climate change. I don't think Rachel is here, so maybe Katie, if you'll raise your hand if anybody wants to follow up on issues of economic development. You should know that the most recent G8 round of debt forgiveness provided less than 1/3 to the developing countries whose debt was forgiven than the negative impact of the increase in oil prices. So in other words, it cost them 3 times more for extra oil than they got back for all the debt repayment that we heard so much about. So if we needed any other indication of how interconnected all this is. Paul, thank you very much for coming to Google. I think we'd all like to thank him for coming. We hope you come back again.